Welcome to the training module on PowerXR Programmable Power Technology. This training module will introduce PowerXR Digital Power Solution and its key features. Every electronic device requires a power delivery architecture, which involves supplying the right voltage and current to ICs in the system. The diagram illustrates the typical power delivery system. It consists of power management and control chips and power supply components such as FETs and power inductors. However, today's complex IC components like FPGAs, SoCs, media processors and microcontrollers have the need for multiple power supplies. Note that these voltage requirements aren't necessarily fixed for a given design. Therefore, system designers need custom power supplies to handle the power needs of such components. In addition to the need for many supply voltages, power and reset sequencing, and drifting sensitivity, today's system designers need far more precise and programmable control over the supply voltages. What's now required is a field programmable power supply or system that can provide multiple programmable supply voltages with independently adjustable ramp up and ramp down times, and adjustable sequencing delays between the various supply voltages. Such a power subsystem design provides the system designer with the needed design flexibility. An FPPS provides system design with a programmable power subsystem that adapts to any changes to or new requirements for the system's power supply. An FPPS device supported with a software-based design tool makes it relatively simple to specify the desired supply voltages and get the required bill of materials from the design tool. Further, because the power system is programmable, the power system's outputs can be adjusted within a range of voltages with nothing more than a programmable change to the FPPS controller. For some FPPS controller chips, a serial port allows an onboard microcontroller to adjust the supply voltages during system operation. EXAR's PowerXR is an FPPS controller IC that provides all the benefits of a field programmable power supply without increasing the cost of power supply design. PowerXR ICs integrate the low cost and flexibility of digital power control as well as the robust power capabilities of high-performance analog power switches. In addition to the programmable supply voltages, the PowerXR devices can control the power up and power down characteristics of the voltage supplies. It can independently control the ramping speed for each of the 4 voltage channels, and it can control the relative timings between the supply voltages. This last characteristic allows the system designer to bring up some supply voltages before others, as required by many complex logic ICs such as FPGAs, media processors, ASICs, SoCs, and ASSPs. Here shows the simplified block diagram of EXAR PowerXR products. The PowerXR has several digital pulse width modulation DPWM controller with integrated gate drivers for use in synchronous buck switching regulators. Each digital controller provides a number of safety features such as overcurrent protection OCP and overvoltage protection OVP. The chip also provides over-temperature protection OTP and undervoltage lockout UVLO for 2 input voltage rails. It also has up to 5 GPIOs and a standby linear regulator to provide standby power. An I2C bus interface is provided to program the ICs as well as to communicate with the host for fault reporting and handling, power rail monitoring, channel enable and disable, standby LDO voltage reconfiguration, and standby LDO enable and disable. The PowerXR family offers a wide input voltage range and output range, that is 0.9 volts to 5 volts, with a built-in low dropout regulator, or LDO, for standby power, power sequencing capability, and integrated gate drivers. These power system ICs contain multiple digital pulse width modulator DPWM ICs with an effective 12-bit resolution. The IC contains an integrated LDO regulator that provides a 5th voltage supply, which can also be employed as a standby voltage source, and is fully configurable via an I2C interface for monitoring control and management of DC to DC power conversion. The device contains integrated gate drivers for the I-current outputs and up to 6 general-purpose input or output pins. The ICs use a digital PID control algorithm that performs full digital loop control at switching frequencies up to 1.5 MHz. PowerXR device reduces design effort by using simple GUI instead of changing hardware, reduces risk by enabling customer to repair or upgrade power supply design when already at end customer location, and use common platform across multiple customer designs. The Power SoC solution replaces cumbersome discrete solutions, thus reducing footprint and cost of passive components. The PowerXR family is comprised of 5 pulse width modulated step-down DC to DC controllers with a built-in LDO for standby power and GPIOs. The XRP 7704, 7708, 7713, 7714 and 7740 devices provide a complete power management solution in one IC and are fully programmable via the included I2C serial interface. Independent digital pulse width modulator channels regulate output voltages and provide all required protection functions such as current limiting and overvoltage protection. PowerXR family offers an unprecedented level of programmability and flexibility for applications requiring up to 5 amps, 8 amps or 15 amps. These applications include consumer electronics, computing devices, industrial equipment, medical equipment, and networking and telecommunications equipment. EXAR's Digital Power Studio enables designers to intelligently configure the power supply's voltage setting and current thresholds, fault monitoring and response, soft start and active shutdown timings, and channel sequencing, phase shift management, and loop response, amongst other features. You may download the latest DPS from EXAR site to start and finish your design today. The design tool accelerates time to market from first meeting to production and enable a wide range of design engineers to leverage their level of expertise for optimal design.